Hi, we're back on our second podcast. Thanks for joining us. I'm Dan,
And I'm Cindi.
and today we're going to cover what we mean by risk and problems and hopefully some mitigation strategies in the business. But before we get too far, we spoke last time about how critical terminology really is. And so this time is no different. Of course, in Data Vault land, that's what we really do is we define terms and then we stick to the terms so that we all know what we're talking about. So today I'd like to kind of talk about risk and problems. And with that, the Oxford English Dictionary defines risk as a situation involving exposure to danger. And of course, the Oxford English Dictionary also defines problems, and it defines it this way: a matter or situation regarded as unwelcome or harmful and needing to be dealt with and, of course, overcome. And that's where the mitigation strategies come in. But we want to really talk about how these risks are manifested or being realized and what we can do about them.
So, if I may, I'd like to share a little story. I have with regard to terminology, I have a real kind of a sticking point with regard to what is a problem and what is a risk. And we were talking about this a little bit earlier, that oftentimes problems are identified and they're perhaps defined as risk. The issue is that risk, when they're actually manifested, are actually risks that are realized. They're not just a risk. They now have to be mitigated because they're actually in process. So I was working with a client a number of years ago, and we had been encouraged to move our Data Vault objects into production ahead of time. We all know how important testing is, and we had been assured that testers had completed all their tests and things of that nature. When we moved into production, I actually intentionally went on vacation for 3 weeks. And when I came back, I walked in, and the engineering team was very proud of themselves. They had put 250 stickies up on the wall, and they showed me the stickies, and they said, "These are all the bugs we found in production. And, now we're going to fix them." And I said, "Well, actually, what you have here are 250 risks that you have now realized. These are not just fixes or bugs or problems. These are risks that have been realized. And so now we have a bigger problem because you have exposure because of the risks that you've encountered and made production." So anyway, one of the things that we were able to do with Data Vault was actually go through those 250 realized risks and actually expose where, in fact, certain things were not risk or problems. They were a misinterpretation of the data. There were processes that were, needed to be refactored. There were interpretations that needed to be clarified. And in fact, there were some issues with data that should have been caught in testing, but we were able to actually take the processes, the modeling aspects, and basically the data quality, I would say, methods that are embedded in Data Vault, and actually help identify what were true risks realized and what were simply a misinterpretation or a failure to truly understand the data. So it's an interesting dilemma we run into once in a while.
Absolutely. It sounds kind of needy, but the programmers, I'm sure they didn't understand it from the business perspective. But we're going to try to uncover some of that today. So some of the top risks we see in analytics programs at the business level include or start with audit compliance. As an example, when I first went public with the Data Vault, I was hearing how data warehouses and analytics solutions really needed to massage the data, change the data before storing it in the data warehouse, and run it through all these business rules, clean it up, if you will, and sweep all the problems under the rug and make it align and all these things. And I said, no, you don't understand. Data warehouses really should be auditable. And according to Bill Inman, the original definition of data warehouse, or part of it, was to be immutable, right? A version of the facts at a point in time. People didn't catch that nuance. They thought, well, I'm going to build a data warehouse, and then they would change the data. Even in the data warehouse, they would change it. So when I started coming out of Lockheed and I told the world, hey, look, analytics really should be auditable and you should have this repeatable process and you should be able to prove where this data comes from. I was always asking the question to these companies, how do you mitigate the risk of an audit compliance? How do you keep your data set in your warehouse in compliance with an audit if an auditor shows up? And they didn't have a good answer. No one really was prepared for that. But then, of course, Enron failed and WorldCom failed, and then the laws changed. And thank God the industry actually matured at that point. They started focusing on auditing and saying, well, our data warehouse has to be auditable now. And I was kind of already in place with that, with the data vault methodology and the modeling constructs and all of that. So cleared the way. And what we really had done with the data vault methodology and the architecture of the data warehouse is followed Bill Inman's definition of what a data warehouse really should be, almost to a T. Immutable was the key word there, at the lowest possible level of granularity that is usable or auditable by the business. So that data vault methodology really had all of that stuff in place and allowed us to springboard into financial systems. The financial community was the first to pick up a lot of these compliance initiatives for audit compliance, and that's sort of where all that came from. So then, of course, we moved on to another type of risk where we talked about ever-changing global security and privacy policies. And today, this is more relevant than ever. If you're looking at today's security and privacy, you've got laws, GDPR laws and PII laws that pervade every country in the world. And if they don't pervade a certain country, it's because they're either they're not interested in technology and what the data does, or they just haven't gotten there yet. But I can almost guarantee you that every country is either working on or has a lot of these privacy laws in place. So when you're talking about global and you're talking about data lakes today, which is another huge, massive undertaking, you can't think about a data lake with distributed governance without thinking about or considering global security and distributed privacy policies and what it means to have, quote unquote, the same data or similar data in two different customer systems in two different countries. By that, you get a company like Lockheed or Raytheon or one of these others. TD Bank, for example, has multiple countries they operate in, and you go across country lines and they're not allowed by privacy law to share data from Canada to the US. So what happens if a US citizen has a bank account at TD Bank and goes over the line and wants to use their teller card, and the Canadian executives want to understand what are the analytics around their teller usage and what kind of data can they pull on a US citizen? So there's a lot of things to consider, and there's a lot of risks to consider in who has access to what data and why. It's no longer good enough that you're just a CIO or C-level or an executive to simply walk in the IT office and say, I demand to see this data because I'm a C-level exec. That could land you in jail. There's a lot of things to do at an IT level and at a methodology level to encrypt data so that you can run analytics, but that you can't actually identify the individuals that are sharing the data inside the systems over the wire and across the pond. The bottom line there is to mitigate those, you need a combination of methodology and approach. And every single IT team needs to be taught the methodology and the approach, needs to understand what to do in order to stay in compliance to mitigate the risk. But then there's distributed governance and distributed operations, right? You can't run a global center of excellence that tells each team, here's how you're going to do this. But every team needs to comply with the standards they're given and then operate locally.
There's a couple of things that come to mind as you talk about this. Is that I think there's a couple of risks that are actually out there that we've recognized in the data vault, I would say data vault land, that the business may not even realize. And these are some of what I consider intrinsic benefits of data vault. But can you speak about, oftentimes a business really has no insight into the operational systems with regard to broken processes, or perhaps with regard to operational areas, functional units that aren't following necessarily their own business process. And we sort of see this in the data vault as a result of the data quality checks we're doing and things like that. Can you talk about that for a minute as a risk?
Yeah, I see that all over the place. I used to say to people back when I was teaching these classes in the early days that there is gold in truly bad data. And people would look at me funny. What do you mean gold in the bad data? Well, it's not gold in the bad data itself. It's gold in the analytics of the bad data. You see, understanding why the data is bad and what's causing it to be bad is, especially if it's driven by an operational system, on a consistent basis. Understanding those particular things allow you to point at certain aspects of the operational system and discover the source of the problem. You see, everybody thinks about data quality. And as soon as I say that, all of a sudden, there we go again, data quality. He's going to talk about, no, I'm not. That's not the point of this podcast. The point of this podcast is talk about risk. The risk is, what do you do to find the problem in the operational systems when it occurs? How do you know there's a problem there? And, if you don't fix the problem, you end up spending, as a business exec, you end up spending 5 to 7 times the amount of money on IT trying to fix the problem retroactively in the data, as opposed to spending the money once proactively in the operational system where it belongs. So it isn't just data quality. This to mitigate this kind of risk with insight into operational systems and where these problems happen, you really got to look at the operational system and the processes that are driving that. And then you need to ask the question, so how do I find the problem? And that's where the bad data comes in, understanding the analytics of bad data. If I'm missing contract numbers off of contracts, or I'm missing customer identifiers off of portfolios, or I'm missing salespeople's badge IDs, how do I pay the salespeople if they're on a time card system? So these are operational questions that impact the business. And in some cases, multiple millions of dollars every month or every quarter or every year. And when you get to those levels, you need to understand first off, where is it happening? How frequently is it happening? And that's what the bad data will tell you. And you need to be able to store that bad data in your data warehouse. And that's what the data vault gives you. The data vault processes are defined to allow that to come in. And the data vault methodology defines what you do with it. And then, of course, you need analytics about bad data. And these are different kinds of dashboards. They aren't your typical IT dashboard or your typical executive business dashboard that show you how many sales you got this month. These are different kinds of dashboards that usually should raise alerts. So if 30% of your data is bad, if 30% of the contracts you have don't have a contract number, how do you use that data? And we went through one of those cases just earlier in the podcast. You were talking about this, where data was missing. How do you do that? How do you define where that data is coming from? How frequently is it happening? How many different systems around the world is this happening to? And so those are the analytics that you want to drive. Then once you discover where it's happening and how frequently and to which data sets, then you can point back to the operational systems and go, okay, now we need to figure out what part of the operational system's causing this or allowing this to happen. And then you need to fix or invest. As a business person, you need to invest in the operational system where the fix really belongs, and not throw your money 5 times the amount of money or 7 times the amount of money at the IT and point at them and say, you fix this problem. That's the wrong place to do it. If you do it in the operational system, then you can clearly clear it up once, and everything flows a lot smoother downstream. This sort of lends itself to the idea of one of the principles we used to talk about called master data management. In master data management, that's definitely what we need to address. Understanding, where the problems are, how to master the data, how to fix the data. This is also total quality management, otherwise known as TQM. And so that's important as well, is to understand how TQM actually helps to solve the problem. So an example of missing keys, I talked about this before in the last podcast, missing business keys in the operational system, what it meant to Lockheed Martin, for example. And if you go back to the last podcast, you'll hear the financial story about how Lockheed Martin misbilled the US government for over 15 or 20 years because they had missing business keys in the operational system at the contract level. And because they actually had time card hours that were attached to those contracts. So theoretically, the subtotals came up with the contract saying there were hours billed, but they didn't see the contracts in the detail listing because they were missing the contract numbers. So this is an example of not having insight into the issues with operational systems. And the data vault is very good. The methodology, the architecture, the model, it's all geared towards loading this bad data in such a way that you can run analytics on it and you can find out where these missing keys are or where they're coming from and how frequently and all of that, and then do something about it. It's not just a haphazard file store sitting in a staging area or what some people like to call a data lake, which we'll get into on another podcast down the road, defining data lakes and data dumps and data junkyards and so on. But to get back to the point, insights to operational systems and issues, it's not just the operational systems that need to be fixed. Sometimes it's actually the operational processes. There was a telecommunications company for short that I was working with through the years. And they had bad business practice of incentivizing their salespeople incorrectly. But the only way you would know that is if you looked at where the data set broke the business rules in the analytics. So the analytics said, we don't want this type of a rule. We don't expect this to happen, where a salesperson touches more than 100 customers every day. But if you look at the incentive said, we're going to bonus the salesperson for every customer they touch. The intention was that if the customer touched or the salesperson touched a customer record, that they would be doing something with that customer. In other words, talking to the customer, helping the customer, clarifying the customer's data, making the system better, understanding that there's customer service attached. But that's what the business thought when they built that incentive. They built the wrong incentive, because what happened next was all the salespeople, rightfully so, got their bonuses because they thought, well, if I just touch this customer record, then I can, and I do it 150 times a day, then therefore, I can earn my bonus. So it wasn't the salesperson's fault, but they were using a loophole in the system. Now, that's not an example of necessarily bad data. It's an example of an operational process gone wrong or an incentive gone wrong. But unless you look at the data set instead of what is required by other data warehousing processes, if you can't look at the data set in its raw form, which is what the Data Vault allows you to do, then you can't run an analytic on it. You can't find out where this problem lives. So just to wrap up this topic, I said a minute ago that other data warehousing methodologies don't really allow you to address insight into issues with operational systems. They don't allow you to see the problems. And why is that? Why did I say that? Because most other methodologies that deal with data warehousing, including some of the things you're hearing about building data lakes, they tell you to take the raw data and munge it and use business rules and business logic and clean it up and sweep all these problems under the rug. And so by the time you munge it, these problems are gone. You don't see them anymore because IT does group buys, they do order buys, they run it through different processes, they do lookups, and when the data doesn't match, they filter it. You've done this before with Excel spreadsheets. You take data and go, well, this looks wrong, so I'm just going to ignore that row or filter that row out. And that's not the right approach. In order to see the operational systems, you have to put on a different pair of glasses with a different color, different lens color. And you need to do the opposite of what you would do for business data. And you need to look for outliers and things that don't fit within the norm and things that look odd and look weird and run analytics on those. And that's how you see the issues with the operational systems. And for that, you need raw data sets. And that's the way the data vault is built. So that rolls up that type of risk. We're going to move on now and talk a little bit about distraction of the shiny object and why that is a risk for companies. We see this over and over and over again in the IT industry, as well as data warehousing and analytics. The shiny object risk is, oh, look, what's the buzzword of today? Oh, look, what's the technology of today? Oh, look, what's the tool of today? Let's buy that. That'll solve all our problems, right? And we have a problem with speed to delivery, just buy a tool, right? That's not going to solve it. But this is what companies often think, and this is what they say. And they're sold on a lot of the marketing and the hype. And I don't mean anything bad to the vendors that are positioning themselves this way. The vendors and the tools and the innovations, they sure do offer quite a lot of goodness in terms of innovation speed and speed to delivery. And one of the things that we've noticed, the shiny object syndrome causes, or the risk of shiny object or jumping on the bandwagon, is you jump on it too soon without knowing why or what you're going to do or how you're going to apply it to solve particular business problems, right? So trying to make the tech solve a problem when there is no methodology or any risk that you've actually identified to address, or any problem in the data that you've identified to address. This is an issue. If you don't have a methodology, how do you work with the tool in a consistent way, especially in a globally distributed team? And that just is a recurring theme today. The bigger the company, the more likely you are to have globally distributed teams. It's just going to happen. Even if you're not global, you're going to have distributed teams, especially in this virtual environment around the world. Not giving into the shiny object is an important thing to do. It's okay to investigate the new technologies. It's okay to look for them, but a shiny object isn't a business problem waiting to happen, or a business solution waiting to solve a problem you haven't identified. That's not the way shiny objects should be selected. We used to, years and years and years ago, say, before we select a technology, we need a bake-off. I don't know how many of you remember that term. We need a vendor tool evaluation period, right? We need to be able to look at the technology, and we need a list of, God help us, requirements or use cases, and see whether or not the technology actually meets these use cases. And a lot of people, when I say the word use case, they think immediately a business saying, I want this analytic. Well, that isn't all there is to it. When you build a data warehouse or a data lake or a data mesh or anything else that's conceptual, and you want to try to build a physical to it, you need an implementation strategy. You need a methodology. You need an approach, and you need consistency, and you need standards. So in order to pick tools that would help you solve some of these issues, things like delivery time come to mind. Well, that's ways of working. That's how people work together. And it's also consistency. How do you reduce errors in the way people work? Well, that's templatizing, right? Taking a business process or an IT process and a way of working and trying to figure out how to put a template in place. Well, then you need a very specific tool that can leverage that template. And then you're talking about code generation, and then you're talking about architecture generation and forward engineering and so on and so forth. So there's a lot of different problems that need to be solved when you talk about distraction of the shiny object. And what does it mean? Just jumping on the bandwagon doesn't really work. And I'll give you a short story here. Claudia Imhoff's a good friend of mine, and she said once that she was sitting on the plane next to an executive and heard this executive, she was talking to him and so on. And he looked over and said, well, I need one of those data warehouse thingies or data lake thingies or whatever it was. And she just laughed, because clearly he didn't understand. But she asked him, well, why do you say that? Why do you need one of those? And apparently he said, well, because I got a call the other day and my IT person said I need it. This is the shiny object syndrome. This is the epitome of that. Let's just go pour some money down in a tool and just buy a tool because it says it can do X or Y, without understanding whether or not X or Y actually solves your business problem. So then you've just lost money, right? As a business user or an executive or a sponsor. So simply having tooling or a new platform does not a methodology make, right? So you need a methodology, you need an approach, you need ways of working, You have to think about people, process, and technology in order to mitigate risk. And the Data Vault methodology or Data Vault solution brings these things to the table for you.
Dan, if I were to step into the business's shoes for a few minutes, and I think about terms like methodology, for example, and I think about terms like a framework. Often we'll talk about frameworks. Can you explain to me as a business user, as management, what is the difference between a framework and a methodology? And why does a methodology, especially one that focuses on people, process, and technology, pulls the triune together, if you will, why is that so important over, say, a software or a hardware tooling solution? What is the difference?
A framework tells you what you need. CMM is a framework. Okay. And that's capability maturity model for those of you listening. It comes out of Carnegie Mellon and the Software Engineering Institute, otherwise known as SEI. So whereas Data Vault 2 is a methodology, methodology. So a framework will tell you what you need, but it won't tell you how to build it. And this is where people get confused. So the framework says, well, you need this and you need that. If you look at data mesh and you look at Zemek's definition of data mesh, you start to realize if you read some of the books that she's written or some of the articles or watch some of the YouTube videos, you start to realize that not only is a concept, but it's embodied almost in a framework. It's not quite a framework, but it does tell you some of the things you need, but it doesn't tell you how. It doesn't tell you how to build it. It doesn't tell you what, how to put the people together, how to put the technology together. It doesn't give you instructions on ways of working or standards or any of those kinds of things. So frameworks will tell you what you need without telling you how to actually accomplish the task. And we talked last time about Roche presenting at the conference. And so I'll just bring that back a little bit. I was having a conversation at lunch with the gentleman from Roche, and what Paul said was interesting. He said, well, he asked Zemek, how do you build a data mesh? And the answer from Zemek was, it's out of scope. So this is why, again, in the last podcast, we touched on this, that Data Vault comes to that part of the equation. Data Vault's a methodology, and a methodology tells you how to do things. A methodology might tell you what you need under the covers in order to build, but a methodology actually tells you how to build and how to build properly and how to build efficiently. Hopefully, good methodologies at least will do that. And then, they supplement or augment the framework. So the framework gives you the vision and the overall scope and the big picture, and the methodology gives you the how-to components of each one of the sections or slices within the framework that you want to implement.
So the other thing I was going to sort of ask you about, I want to kind of go back to the operational systems and some of the things that get hidden in the operational systems. With regard to data science, I was at a symposium a number of years ago and was very interesting. It was with a number of members of I would say the 3-letter intelligence agencies that were all talking about data science and analytics. And it was one of the gentlemen, he's the deputy director of one of the data science at one of the agencies, made a comment, which I found quite fascinating, a little bit disconcerting, honestly. But he was saying that, there's a real issue with the AI algorithms with regard to their, I would say, fragility, and they're so dependent on the data. And one of his comments was, we really need a way to govern data because all of these data science approaches, whether it's AI or ML or natural language processing, machine learning, these, deep learning systems, they all rely on what they would call, or what we term, curated data, quality data. And so one of the things that struck me was the comment around and the discussion around this need for, we need to find a way to manage like data governance and these pieces that we have actually been doing for years inside of the data warehousing industry as a whole. These are problems we've been addressing. We're actually quite good at that. How would you potentially, for the business, sort of explain or describe why Data Vault as a methodology actually does incorporate the pieces that are needed? And I know it's much more of a discussion than we can get into today, but just touch on maybe some things we can begin to explore in future podcasts. Touch on what aspects of Data Vault actually do address some of these approaches for data engineering and data management that actually help the data scientists in this area of curated data.
Yeah, we actually had a couple of presentations at this year's conference that focus on using Data Vault for AI and ML. They not only expose what you can do with AI and ML on top of a Data Vault and why to use Data Vault for that particular activity, but they also focus on what happens when you get the wrong answer. Heli's presentation from Finland covered what happens when you get the wrong outcome and what you do with it. But I'll bring this back to the business level. So first thing I want to say is, look, AI and ML, they're here to stay, no doubt, no question. And companies that aren't learning how to leverage them today are going to be behind the eight ball literally tomorrow if they aren't already. AI and ML at the same time, is that a shiny object? I think it depends. I think there's room for traditional analytics. Don't throw away traditional analytics just because you've got AI and ML and data science on the rise. But also don't just implement data science and AI and ML just because it's the thing to do. Once again, you should have business goals and you should have use cases where you're going to save money. AI and ML is best today, at least, at directed outcomes, very narrow and very governed types of processes. Think about it as a scientific process where you're developing a drug in a lab that will affect the human. And imagine what kind of trials, clinical trials, human trials, or other types of trials that this drug has to go through before it ever is introduced to human for consumption and use, right? So there's safety nets and there's all kinds of other things in place to make sure that people hypothetically don't die from just taking this in mass, of course, taking this new drug. Well, it's the same thing. AI and ML is highly focused on trying to understand the impact of a particular narrow decision. And with that, there's an old saying that I like to use for analytics that says you need twice as much data to make half as good a prediction. So if you're going to predict the next 6 months in terms of forward thinking, you need at least 2 years of data or so, right? 6 months times 2, well, that's 1 year worth of data. It's good, but 2 years is better, right? And 3 years is better than 2 years, and so on and so forth. Well, AI is, imagine, 4 times that multiplier. Not only is it necessary to have more data, but it's also a better idea or a good idea to understand the quality of the data itself, because there is such a thing as false positives. And believe it or not, there's even something now called data poisoning. And this is something I read about recently. I'm sure it's been around a lot longer than this, where your competitor will sneak someone in to, quote, poison your data on purpose. They'll put bad data in the stream on purpose to affect your AI and ML. The sad part is, unless you're actually actively looking for this poison data, you're not going to find it. And it's going to lead you, if you run it through a simple AI ML, nothing simple about AI and ML. If you run it through an AI ML algorithm that you've developed over the years, if you're not actively looking for, quote, outliers or poison data or, quote unquote, bad data, it's going to be included in your decision process and very well could lead you to the wrong decision. And that's what poison data is all about. So interesting things. The definition of the word virus is changing to include poison data. So these are things to think about. But AI and ML is clearly here to stay. It's a competitive advantage when it's used properly. And the Data Vault gives the ability to the data scientists to isolate certain areas of data, connect other areas of data and pull outcomes that they otherwise wouldn't have seen, as opposed to it reaching into a giant unstructured data storage area, which some people call a data lake. The data vault categorizes and organizes all that data by business key, which we like to call ontologies and taxonomies. And so that's one of the big things that Data Vault brings to the table for AI and data scientists.
I think we're probably out of time, unfortunately. So I look forward to getting into some of these other topics as we start to continue to define terminology, understand what Data Vault is and how it actually benefits the business. So looking forward to future discussions coming soon.
Yeah, me too. Thanks for listening, everyone. We'll see you next time.